Hello and welcome to this private 5G for SMEs, the potential competitive advantage. I'm Roberto Ercole. I'm the sector lead for digital infrastructure and telecoms. We've got three other speakers today. Andrew Lambert, who's the CEO of EMS, will be talking about the power of private 5G and how that connectivity can help you. We also have Jack Hendley, a policy principal at Ofcom, and he'll talk about how to get access to spectrum for private 5G networks. Then we have Ben Willis, who's a principal technology advisor at Ofcom. He'll be looking at the best practice on security and what we've learned from public networks. And at the end of those three sessions, including mine making it 4, we will have a Q&A and we'll answer some of the questions that come in. So next slide, please. Next slide. So BSI, we are an organisation that was set up in 1901 by Royal Charter. One of the key sort of things that we look at is to inspire trust, to share knowledge and innovation, business improvement through standards. And we do voluntary market-led standards with legitimacy through consensus and public consultation. And you can see on the box on the right some of the benefits that accrue from that sort of approach. So improved productivity, increased efficiency, and reducing costs and accelerating innovation. So one of the things we're keen to understand and explore is if the complexity in private 5G is a sort of barrier, particularly to SMEs. And that's one of the things I'd like to address in my discussion. Next slide, please. So I'm going to talk a little bit about what SMEs and private can benefit from private 5G, talk a little bit about what private 5G is. I'm sure most of you have heard, if not all of you, that 5G is a key technology for AI and IoT and productive efficiency, and it's being used in things like construction and manufacturing and farming and transport and ports as well. So the interest in private 5G is having a localized service. So one where you're not tied into the quality of service provided by the public network. You've got something bespoke for industrial applications, which might be higher than offered in the public network. And we've seen activity in Europe and the US, particularly for high-value manufacturers such as the automotive industry. So being such a large number of SMEs in the UK, 5,500 with a 2.3 billion turnover, about 50% of all turnover, you know, it's a large area, and one of the things that concerns BSI is there might be a lot of duplication of effort in every SME trying to understand this issue and approaching it from scratch. And if there's some benefit from convening a process where people can share information and have that peer review, if that would accelerate the deployment of private 5G for SMEs. So next slide, please. So this is just looking at the capabilities of 5G. If you look at the triangle on the right, there are kind of three sort of areas. The enhanced mobile broadband, so that's just much higher data rates than was available at 4G. The massive IoT at the bottom left. Internet of Things, so IoT on 5G is supposed to be able to offer much higher densities, perhaps 1 million devices per square kilometre rather than 2,000 per square kilometre. So that makes it ideal for industrial processes. Having much better power efficiency and power management. So a device battery might last for a year on 4G for IoT, whereas for 5G, they're projecting something like 10 years. And you can see other things like mission critical services, so ambulances and emergency services. And this is to do with things like lower latency and lower delay, making it more suitable than perhaps 4G for self-driving vehicles and office automation. These slides are from Accenture, and it shows the differences on the left where you can see it's compared to Wi-Fi. So the latency is better than Wi-Fi of a few seconds to 55 milliseconds with 4G and less than 10 milliseconds with 5G. Although public 5G networks can be higher than that. So these kind of benefits will depend on the private network you deploy. Next slide, please. So this is a look at what private 5G is. The box on the right, the picture on the right is from Verizon. This is from their kind of advertising literature. And this is what they're talking about. So it's not just about speed. Private 5G is inherently more secure, is at the top on the right. It's not the same as public 5G. Every business has its own dedicated spectrum, and basically you design the quality of service that you need. One of the issues with public networks is that the signal strength might not be so strong indoors, and I'm sure that Ben will talk to that. And you can have a higher security, perhaps, than Wi-Fi. It's not only for innovations, so with 5G, it's revolutionary changes. That's how they're doing it. And what you can see from this picture is you can connect multiple sites. So if you had one site, that's one option, but you could have 2, 3, 4, 5 sites connected together. For that, you'd need some kind of lease line or interconnectivity to do that. And they're obviously saying it's not the same as Wi-Fi 6, so it's perhaps an enhancement that sits on top of Wi-Fi 6. So that's sort of covered in the bullets. You get better indoor coverage, but you need access from a spectrum license. So for that, sorry, it's Jack that's doing the spectrum, apologies. So Jack would be able to speak to that. One of the things might be that 5G kit is more expensive. AWS is Amazon Wireless Services. This is something I got off their internet site, across 4 or 3 base station units covering a large manufacturing facility. They've given the cost here over 33 months as around $250,000. I'm not sure how applicable that is to the UK. And as with most things, you see the price will come down with economies of scale and adoption. So hopefully that price would come down, but that maybe gives an indication. And that's something we'll discuss in the Q&A afterwards. So next slide, please. So this is just a look at the sort of things that businesses find are important. So reliable indoor coverage. So the darker red line is how important out of 10 businesses find this from a survey. And so, for example, coverage 8.3 is how important out of 10 they find it. 5.4 is the kind of experience that they have. So that would be quite a major benefit from a private 5G network. You could have your own base stations or nodes which cover your building to give you that higher availability, that higher signal strength. And then you can see the other things, predictable QoS, critical availability, lower latency. So these are the sorts of things that you look for in a public network, but that might not be available necessarily because you're sharing it with public users, and the location of the base station from the public network might not give you the quality that you're looking for. So if we move to the next slide. So this is an example for Ford. I think it's in the US, a factory floor automation and robotics process control. These are numbers that are quoted in the Accenture report, a 20 to 30% improvement in productivity, a 40% increase in usability, and a 30% increase in efficiency. And the little box at the bottom is the enhanced mobile broadband. So that's the data rate, is 2 out of 4 importance, but the massive IoT, that's quite important, 3 out of 4. And the mission critical service, so that's perhaps the low latency and high availability for controlling machines and robots in a factory, is given as the top priority in this user focus, in this use case. This figure 40 is taken from a survey of UK SMEs. This is from 2019. It looks at the top priority and not a top priority. So you can see top priority for UK SMEs was 30% product innovation, both product and process innovations quite high, 51%. So this kind of signals perhaps that things like private 5G could be important to SMEs for increasing their product and process innovation. So perhaps one of the advantages in a factory, it would be more reconfigurable if your robots and things were connected via Wi-Fi than via a cable. So if you could use Wi-Fi, but that might not be as reliable as you want. And if you use private 5G, that gives you the mission critical service availability. And then your factory can reconfigure itself between different production runs or different services. So that could be of benefit. So 51% of UK SMEs consider digitization a top priority in this survey, and private 5G might be a way of achieving that. So if you go to the next slide. So obviously the important thing is how would you get private 5G? There's probably three main types of doing this. One would be for a mobile network to build this. So that's called in some literature hosted. So you get a Vodafone to come into your factory and they say they can provide the coverage for this cost and this quality, and they maybe put some base station units on your site, and that gives you the coverage. So you ask the MNO to build that and you have a contract. And that's good in some ways in that you have the MNO does it, they provide a guarantee and quality, and there's less kind of risk on the private, on the industrial partner. The other way is they could ask a third party to build it. So this might be a hosted, and perhaps this is sort of thing Andrew can talk to. The benefit of that is that you might be able to share some of the elements with other parties. So if it was on a business park or in another area where there's more than one user, then you can share elements and you still get some of the benefits of the hosted. And the other way is option 3 is to build it yourself through various subcontractors, and you need the necessary spectrum license from Ofcom. Obviously, the advantage of that is you have perhaps more control of the costs. Perhaps the operating cost is less, but the capital cost is higher. If we move to the next slide. So these are people in the market. This is taken from a European-wide report. So you can see you have the mobile operators. You have people like IBM and Intel as kind of system integrators. And then you have network equipment providers, and there are a number of those available. If we go to the next slide. So this is quite a busy slide. The main takeaways from this is what it's looking at is, if you look at that index 100, that's perhaps the benefit of going to private 5G. If I had a private 5G network, that's the benefit. Now, if I went to a hosted MPN, so that's basically asking an MNO to build that, to do that for you. If the MNO's network covers you, they don't need to do very much, i.e. reuse the radio access network, then that's the lowest cost way of doing it, and there's quite a bit of benefit. So you could see, there's 47% at the top there available as benefit to be shared between the MNO and the provider and the factory. A hosted one, again, this is where a third party comes in. This is because there isn't very good network coverage from the public network, so they need to build more. So you can see there's that 45% in the darker blue. There's more build required there for the radio access network, so there's less to share. And again, the hybrid. Hybrid is where you share similar to the hosted MPN. And then you have the on-premise, which is where mobile private network, which is where you build it yourself as an SME. That perhaps is the biggest benefit, depending on the circumstances. Then the columns on the right, that's where you have more than one site, so they're not comparable. So the column on the box on the left, that was where you're doing a single site. When you have multiple sites to connect, it becomes more expensive to do an on-site premise where you do it yourself, because you've got to connect various sites together. And what this is suggesting is that might not be that cost effective, and the other methods may be more cost effective. So getting it from an MNO or a hybrid might be more cost effective because they can connect your sites together better. So if we go to the next slide. This is just the number of identified customers who are actually using private networks. This is from GSA, who's the network supplier organization on mobile equipment. So you can see manufacturing is quite big, mining, education, seaports and maritime, smart cities. So you can see the number there. So manufacturing obviously is a big one. So production, as well as mining is quite big. So these are the sorts of areas where you might see it being used for, where it has been used. So this shows there's some sort of commercial drive for that. But some of these organizations won't be SMEs, obviously they'll be bigger. Next slide, please. So as I said at the beginning of the slide, one issue might be the lack of information for buyers. And a lot of SMEs who are coming into this area thinking they would like private 5G, but perhaps don't know that much about it, don't know the differences between buying it from an MNO, getting it from a third-party hybrid, or the self-build on what you need to do to do the self-build. And that sort of uncertainty can add to cost effectively, because you've got to do a lot of research, and perhaps it's quite difficult for an SME to do that. So there might be some benefit for third-party trusted information. So that's the kind of interest from BSI. Next slide, please. So if I look at it from a BSI kind of perspective, when we look at this innovation cycle from the diagram on the right, you can see that we're kind of in the beginning phase. There doesn't appear to be a large number of private 5G networks, certainly not compared to the 5.5 million SMEs in the UK. And so we might be in the stage of bringing stakeholders together, preparing the market readiness, and so that there we can move towards maybe a code of practice or something, guidance to help SMEs prime the market and move forward. Now, most of the work done for standardization for 5G is done within an organization called 3GPP, Third Generation Partnership Project, I think. But that's a global organization which mainly the mobile network operators and the equipment vendors go to. And it's obviously quite difficult for an SME to be involved in that and understand those sorts of meetings. But what might be of benefit is something where there's a group of organizations that put together some information that helps SMEs. And I'd be very happy to discuss that going forward with interesting parties about what sort of information you would think would be useful based on the discussions and the presentations here, and maybe how we could help facilitate that and convene that sort of process. Next slide, please. So these are the sorts of standards that BSI develops. So for industry, for government, for charities, for different organizations. And we see our clients get lots of benefits from developing standards to benefit their process, their industries, their organizations. Next slide. So that's just me. I'm happy to be contacted and discuss this with people, and without a benefit I can offer to an SME, because I think this is quite a complex environment, and it's changing and it's fast moving. So I think there's a lot of benefit for private 5G for organizations, and the costs will come down. But it's important to understand the timings and what the critical factors are, and to make the preparedness to go when the opportunity presents itself. So with that, I would like to hand over to Andrew Lambert. Can we have Andrew Lambert's title slide up, please? So Andrew Lambert is the founder and CEO of EMS Services, and he can offer the experience of how to offer these services to an SME. So with that, I'll hand over to you, Andrew.
Good morning, everybody, and thank you, Robert, for inviting me to speak up on this webinar on this interesting topic. Next slide, please. So, as Robert said, my name is Andrew Lambert. I'm the CEO and founder of Electronic Media Services. We're a technology and telecoms company. We focused on over the last 15 years on providing connectivity at remote and temporary locations. We work across a number of sectors, including construction, local government, and transport and logistics. And our customers include organisations like Tarmac, Humberside Police, York City Council, and DHL. We also install and manage public Wi-Fi. We've installed a private 5G network, and we're also very active on developing edge computing and the use of artificial intelligence and machine learning to solve business issues, and incorporating digital twins. Next slide, please. So as Robert spoke about, there are three pillars of 5G. The one that most people will have come across at the moment when they see the little 5G symbol on the top of their phone is enhanced mobile broadband. This gives users in the current generation of 5G speeds of up to 1 gigabit per second. I mean, I think in the UK it's sort of a few hundred megabits per second rather than the gigabit speeds. The underlying standard is designed to go all the way up to 10 gigabits per second, though, so faster than the current generation of fibre connectivity into your home. The second element is the ultra reliability, low latency mode. This requires some upgrades to the network core, and this hasn't yet been rolled out substantially across the UK. The idea with ultra reliable low latency is to guarantee the delivery of a packet or information, and also to make sure that that packet is delivered in a timely manner. So the sorts of use cases for this are remote surgery or self-driving cars, and of course you'll have all seen the adverts by one of the national network operators about somebody receiving having their face shaved on the top of a mountain. The low latency, ultra reliability, of course, is a critical part of that story. The massive machine type communication Robert has already touched on. This is this ability to have more than 1 million devices connected per square kilometre. That might, I mean, the 4G standard allows 200,000 devices per square kilometre. But if you imagine, say, a match day at a football stadium, most people turn up with at least 1 or 2 phones. It's very easy to see how you could end up with local cell getting congested. In a business environment, if you imagine a port, if you wanted to put a tracking device on every container in a port, then you would easily saturate the local cellular network. Next slide, please. So the question often asked is, why not just use a public network? Well, a public network is a public network, and of course, if you connect critical services and critical systems to a public network, then you expose it to hacking. You certainly wouldn't want to expose critical machines in your factory or in your organisation to external connectivity. So that's one thing. You also have limited control. A public network is a standard network. You get the service you get delivered by the public network. There are no options really to get preferential service. Some of the emergency services have preferential access to the network, but that's about the limit. And you also get some variable performance. So in our business, we see that 3 o'clock in the afternoon, the networks get very busy when all of the schools turn out and all of the children are on their phones. You can see network performance drops at certain times of the day. And obviously there is coverage gaps. No one single operator has 100% coverage of the UK. So with our customers, we end up supplying devices with multiple SIMs and allowing and using the different networks where they have the strongest signal and the best performance. Next slide, please. So the question obviously always asked is why not just use standard Wi-Fi? A single Wi-Fi access point has a limited range, probably under ideal situations, maybe 50 or 60 meters. In the situation you see in this example in the slide, you get shadowing. So I have a friend who operates a warehouse, and they have immense trouble getting coverage across the warehouse using Wi-Fi because of the shadowing from the shelves. When you first start deploying Wi-Fi, you think, oh, there's lots of channels available, but actually there are a very limited number of channels availability, and because of the short range from a Wi-Fi access point, you very easily run into interference and congestion on the network. The other thing with Wi-Fi is some of the higher 5 gigahertz frequency channels are available on a shared basis. Their primary user is weather radar, and if a weather radar is detected, then the access point shuts down for, I think, about 20 minutes between and to make sure the channel isn't in use. And this makes deploying Wi-Fi networks outside quite challenging. I mean, in one of our sites, there isn't any weather radar for a considerable distance, but occasionally when an aircraft flies over the top of the site, there's a signal bounced off and several of the access points all shut down. And roaming between cells on a Wi-Fi network is also quite challenging. Quite often you find that devices hang on to an access point when the service has actually become quite unreliable. Next slide, please. So some of the benefits of private 5G is that you can have your own private spectrum, and I won't go into this in great detail, but because I know Ofcom are going to speak about this next. You have security. You can build a completely isolated island, so no connectivity to the outside world. So if you are connecting critical machines, so machines in your workshop or devices, pumps and things, then they are completely isolated from the public internet. You have the ability to have much more reliability because you control the network. You can prioritize certain types of traffic, and you can put other traffic at lower priority. I mean, it's interesting. One of the benefits that TfL quoted when they first started installing Wi-Fi on the underground stations was how it allowed them to run extra business services. But as the networks became more and more busy in the underground, actually the reliability of those services became more difficult. So with a private network, you're able to prioritize particular applications. And because you can run higher power, a single radio access point has much greater range, so you actually can install fewer access points. Next slide, please. So what makes up a 5G system? So there is there's a 5G core. This is like the brains of the system, and this is computer software usually that either runs in the cloud or it can run on a standard server. Then there is the RAN, the 5G RAN, which is the radio access network. This is the bridge between the brain of the system and the radio waves. And what's interesting and traditionally there have been a very few producers of RAN components, but with the support of the UK government and their diversification strategy, they've been pushing Open RAN, which is an open standard for radio access networks, and this is driving the cost of these components down. So there are smaller players in the market beginning to offer much lower cost radio access networks. The 5G core, as I said, can either be on site or it can be in the cloud, and some of the network providers like some of the satellite network providers like OneWeb have been demonstrating controlling RAN components from remotely, so that the installed component on your site is just the radio access network and not and nothing else. Next slide, please. So some of the impacts of poor connectivity are sort of highlighted on this slide. We have a lot of customers in construction, so we have a lot of experience of this, with new sites being started with poor connectivity and them working with out-of-date information. They have to revert to manual systems, which causes project delays and increased costs. So being able to deploy connectivity where you need it, when you want it, is critical for many businesses. Next slide, please. Construction is, as I say, is an important area for us, and one of the things we are involved with is an organisation called Commit, and Commit promotes the use of technology in the construction sector, and we have a Commit to 5G project that's currently running, and one of the objectives of this project is to demonstrate how easy it is to install and commission a 5G network. So we have the first network that's been rolled out to test this process, and we are able to sort of stand up a network within a day. So it's not a complicated process, and that allows the images from drones to be collected and sent back to the cloud for processing, control of remote machinery, tracking of assets on site, and the use of augmented reality, so the construction workers can see where they're supposed to be working and what the final results are to be like. And workplace health and safety is another important area. Next slide, please. So 5G is an ecosystem. It's not just one component, and there are many opportunities for SMEs in this market. That it's more than just apps on a phone. There is a need for companies who will do systems integration. There are need for companies who do installation of antennas. There are need for companies who produce IoT devices that connect to the network. So if you think of machines connected, devices that will connect to your machine in your factory to collect machine data, so you can identify when manufacturing processes are going out of tolerance, so you're able to go in and fix things quickly. And so the important point here is it's a large ecosystem, and there are many opportunities for SMEs in this 5G landscape. Next slide, please. So in summary, really, 5G gives unmatched speed and reliability. It is quick and easy to deploy. It's a little bit more complicated than Wi-Fi, but the benefits of not having to deploy quite so many base stations overcome that. And the move by the government to support open O-RAN, and that has driven down the costs. And you get sort of controllable latency for real-time applications, and you improve the security of the network. And you can control and customize the network to meet your business need. So next slide, please. So that's the end of my presentation. Here's my contact details if you have any questions. And at this point, I'd like to hand back to Robert.
Okay, thank you very much, Andrew. That was a very interesting presentation about the services you offer and the market. And good to hear that government initiatives like ORAN are driving down costs. So with that, I'd like to pass over to Jack Hindley, who's a policy principal at Ofcom, and he's going to talk about shared access spectrum for private networks. So I guess this is hopefully going to cover, if you're an SME and wanted to build a network, how you would go about getting a license. So, but anyway, over to you, Jack.
Thanks, Roberto. Hello, everyone. Yeah, so as the slide says, I'm Jack Hindley. I'm a principal at Ofcom in the policy and analysis team in our spectrum group. And one of the things I'm currently working on is looking at ensuring our shared access processes and products are up to date and supporting businesses and industry in the best way possible. So I'm going to talk to you a bit more today about shared access and kind of routes to getting access to localized spectrum use. So next slide, please. So what is shared access? Well, this goes back to a product that we first made available in 2019, when we recognized that there was a growing demand and interest from a range of players to localized spectrum access, so access to sharing a slice of spectrum in a particular location in the ways that Andrew and Roberto have described, to allow sort of more local control and customization. We envisage supporting a range of use cases. You've already heard about some of those, and the graphic on the top left kind of gives a bit of an overview of some of the things that we expected to support. And we made spectrum available in a number of bands with some slightly different rules and regulations in each case, helping us to support a range of different applications, as the chart shows. So I'm going to come back to that in more detail in a moment. So let's move on to the next slide, please. So here is that extra detail of what's available. Now, quickly, first on the left-hand side, we do actually have another product that sits alongside our shared access product, which I'll briefly talk about here, and that's a local access product, which gives the potential for interested applicants to look to access spectrum that is available to the mobile operators in certain bands, in circumstances where that spectrum is not being used. So that's an alternative possible route to shared access, but as set out here, there is some extra process around that, where Ofcom needs to liaise with the mobile operators and ensure that there are no plans for that spectrum to be used sort of for the foreseeable future. And it comes typically with a finite period of 3 years of access, on the basis that operators might afterwards be looking to roll out in that area. Those same conditions don't apply to shared access, and that's where we've had the majority of interest and uptake since we started making these products available in 2019. So we have at the moment these 4 bands that spectrum is available in shared access, with different spectrum properties in terms of propagation characteristics, and also the bandwidths that are available. So it's in the 1800 we have 2 times 3.3 megahertz of FDD spectrum available. We have 10 megahertz of spectrum for indoor only use available at the top of the 2.3 gigahertz band. We have bandwidths between 10 and 100 megahertz available in 3.8 to 4.2 gigahertz, and spectrum we're also making available in millimeter wave frequencies. We've got different products, which I'm going to describe in more detail in one of the coming slides, for low power and medium power. And important to note that Ofcom coordinates access on a first come first served basis, and that means that we need to undertake coordination checks to ensure that the way that you're looking to use the spectrum is compatible with the other uses in the area, and basically ensure that users in different locations can share and get along without significant interference. And we do have some costs involved in administering this process as well. So essentially, it's an £80 per megahertz cost. Obviously, that's for 10 megahertz. £80 per 10 megahertz, and with additional bandwidth, the cost increment goes up, but that's generally the process that we've got. Next slide, please. So this gives just a little bit of a sense of the levels of interest that we've seen in shared access to date across the different bands. Actually, since 2019, we've had more than 2,000 licenses that we've issued, but there is some level of churn and turnover in that people perhaps want the licenses for a short period of time and hand them back, or their envisaged uses change. So at the moment, we've got over 1,600 licenses on issue. As you can see, there's sort of a mix across the different bands, a mix of low power, more popular in some bands, medium power, more popular in other bands. I'm probably, for a lot of the rest of the presentation, going to focus on 3.8 to 4.2 gigahertz, because that's where we've seen a lot of the interest, particularly for 5G type users, which we're largely here to talk about today. And there's very much developing 5G ecosystem in that band. One of the things to note in the case of 3.8 to 4.2 gigahertz is that medium power is at the moment only available in rural areas or in urban areas by exception, where the sterilization effect, the impact on other users essentially is reasonably modest. And the image on the right hand side is just to give a sense of that take up across the country. There is definitely interest and use going on sort of in every corner of the UK, although you can also see there are pockets where the activity is stronger and more prevalent in some locations than in others. Next slide, please. So this is just to give a little bit more of a sense of how the two different products, the low power and the medium power products that I've talked about, work. So on the left hand side, we've got the low power product, which authorizes equipment up to 24 dBm. And essentially, you would ask for a sort of center point location to Ofcom, and we would check to ensure that uses at those power levels are not going to cause problems to neighbours in nearby areas. If there is a problem, then certainly in the case of 3.8 to 4.2, there is potentially up to 390 megahertz of spectrum to look for a solution in, and potentially see whether moving channel would help address that problem. But assuming sharing solutions can be found, you would then effectively have access to this 50-meter area to deploy any number of base stations at that power level within that. So on the right-hand side, because we're looking at a higher power level, we undertake that coordination for a single base station fixed point, and then you would of course be able to also operate the terminals that are associated with that base station across a wider area. So fundamentally, it's those two products, different power levels. And with the low power level, the ability to deploy a number of base stations across that 50-meter radius circle. Next slide, please. So with this slide, I just wanted to give a bit of a sense, and building on what some of the other presenters have already talked about, a bit of a snapshot into what we've seen in terms of how the shared access spectrum and the 3.8 to 4.2 gigahertz band in particular is being used. So as you can see from the chart along the bottom, there's a whole range of use cases going on: private networks, FWA, local authorities, universities, logistics, ports we've heard about already, mining facilities, whole range of things going on using this spectrum. And I've called out in some of the images here on the left hand side, FWA provider, companies who are using this for sort of industrial monitoring. 5G video content is also a possibility, supporting additional information and entertainment for tourists and site visitors, potentially going all the way through to some users exploring providing connectivity for autonomous vehicles. So a whole range of possible uses. Next slide, please. Oh, back one, I think we've skipped ahead. Yeah, so just wanted to, in the next couple of slides, give a little bit of detail on the process that how you would go about accessing some of this local spectrum, if that was something you were interested in. Well, essentially, it's a case of coming to us and saying, this is the frequency band that we would be interested in accessing. This is the location that we would like to operate in, or locations, if there are multiple locations. This is the bandwidth that we are looking at. So in the case of the 3.8 to 4.2 gigahertz band, do you need 10 megahertz, do you need 20 megahertz, 40 megahertz, etc. And you're looking at operating at low power level or medium power level. And if it is medium power, the specific power up to 42 dBm that you are looking at operating. We would then undertake coordination checks with other shared access users who are also sharing the band with a number of other incumbents. So essentially to ensure that we can find a clear channel for you where you're not going to experience interference or unduly affect others. And assuming that all goes smoothly, you would then pay us an annual fee, although there is a process for short-term licenses if a short-term license is all that you require. So if we go on to the next slide, please, there's a little bit more detail on where you can find guidance. So yeah, there's a couple of links at the top of this page. One that would take you to a sort of dummy application form, or indeed, if you want to actually fill in the application form, that would be the route you go to, and that gives you a bit of a feel for the kind of information you need to provide. We've tried to keep that relatively simple and straightforward, but you need to tell us things like if you're going to operate indoors or outdoors, and the antenna height that you're looking to operate in, the frequency that you would like to use, etc., etc. There's a guidance document that sets some of the things that I've talked about out in more detail. And bottom right, I've also provided a snapshot of what we call Ofcom's Spectrum Information Portal. And you can go in there and have a look at in a bit more detail. It's got information on licensees who are using the different shared access bands and the different power products. Gives you a bit of a sense of, in more detail, perhaps who's doing what in that spectrum, what companies are involved and have licenses, and also could give you an insight into, is the area that you're looking to operate in a busy area? Are there a lot of users? In which case, important that you ask yourself, what's the bandwidth and the power that I really need, because that's the most likely way to make sure that your application gets through the system quickly and is approved. Next slide, please. Oh, we've skipped ahead one again. If we could go back. Thank you. So as I said at the beginning, one of the things that I'm doing at the moment is looking at the shared access process and products that we've got and making sure that it's fit for the future for the coming years. So we're looking at this in the spirit of evolution rather than revolution. So the principles that I've outlined here should not be changing significantly. We are just thinking about how are the use cases evolving, what's the future demand going to look like, what might users require from us in the future, and can we just make sure that the system is supporting people in the best ways possible. So we are looking at issuing a consultation on some of that thinking in the coming months. Might be one to keep an eye out for. And likely we would move to a statement, which is the process that Ofcom has for implementing any decisions on updates and developments like this at some point next year. Next slide, please, which I think is my last one. So this was just to say and acknowledge, really, obviously we're here talking a lot about shared access and potential use of 5G and for private networks, but just to acknowledge that other solutions are available, and it very much depends from our perspective on, we're not here to advocate specifically for one solution over another. It's about the solution that best fits you and your business needs, and all of these technologies potentially have very significant and important roles to play. So it could be LTE might suit your needs, Wi-Fi might suit your needs, narrowband IoT might suit your needs, etc., etc. But we have certainly recognised that there is this appetite for access to localized spectrum with a mobile ecosystem that can be used for 5G type uses and supports that potential bespoke QoS type functions that we were talking about earlier. And one last point on that in terms of shared access and what it can be used for, particularly relevant, I think, in the 3.8 to 4.2 gigahertz band. You can choose your own frame structures, so your uplink and downlink ratios can be set to your business needs, which potentially again adds to that level of kind of customization and gives you a kind of control over quality of service that's potentially different from some of the other offerings available. So that is all from me. I think I'll hand back to Roberto. Thanks very much.
Okay, thank you very much for that, Jack. That's very interesting discussion. Also, interesting thing for me was that 3.8 to 4.2 gigahertz seems to be a popular band, and I think that's the same sort of frequencies the European Union are thinking. That's obviously very important for the mobile ecosystem and bringing down costs, as Andrew was saying earlier. So with that, then let's move to the next presentation from Jack Hindley. From Ben Willis, who's a principal technology advisor at Ofcom, who'll be talking about the Telecom Security Act and what private 5G can learn from that. So over to you then, Ben.
Thank you very much. So hi everybody. So I thought I'd start with both Roberto and Andrew touched briefly on the sort of benefits of 5G security compared with other technologies, and then private 5G in particular compared with public. And my presentation is really about what private 5G can learn from the regime that we administer, which is security in relation to public 5G networks. So maybe just a little bit of context there. It's certainly true that 5G as a technology has a number of important security improvements over previous generations and other technologies such as Wi-Fi. They cover things like authentication and encryption of control information that flows around the network. So that's the sense in which people often talk about 5G as having good security. But we're not going to talk more about that, as Jack kind of alluded to. Ofcom tries to be sort of technology neutral, and people will choose the technology that suits them, and the security features that come in that technology are what they are. The regime that we look after in relation to public networks is more about how you deploy that technology and keep it secure. It's entirely possible to have a very inherently secure technology and deploy it in a way which creates all sorts of security risks. And so that's really where the regulatory things function, and where I think there's probably some read across from the sorts of things that we have in place there into private networks. So that's the sort of context for this discussion. So I'll give a little bit of background of what's called the Telecoms Security Act, which is some legislation that came into force fairly recently. And the background really to this, we've had some very high level security obligations on providers of public networks for about a decade or so. But they were extremely high level, essentially just a requirement to take appropriate security measures and very little beyond that. Government recognised that that was probably not sufficient in a world in which we now have cybersecurity threats, which were hardly envisaged when these original rules were written, and also where telecoms is increasingly a kind of a backbone to all sorts of parts of the economy and other critical sectors and so on. And with headlines like some of the ones here, either sort of more natural type hazards, so the increasing instances of flooding and so on, affecting the reliability and availability of networks, but also more deliberate cyber attacks and so on. Government were concerned that more was needed in this area, and so that's where the Telecom Security Act came about. Next slide, please. Thank you. So the Act, I should probably just first say, is applies to people who operate publicly available networks and services. So, I would just sort of caveat all of this. I will talk a little bit about the Act and explain what it consists of, but don't panic. These requirements don't by on private networks. A slightly tricky legal concept of the distinction between private and public, but broadly speaking, these apply to public networks, and private networks are things that are not public networks. So, so it's not a kind of a call that you are all of a sudden going to be facing all this new regulation. So the Act kind of breaks into two parts. The one I'll just cover really briefly, because we're not going to talk about this much more, is high risk vendors, and Huawei are the particular vendor that is relevant here at the moment. So this was something which gives the government the power to designate vendors as high risk, and say Huawei has duly been designated, and then place restrictions on providers of public networks and services in their use of Huawei equipment and services. So there's a range of deadlines that are coming up over the coming years, which essentially require the operators of mobile, fixed and other networks to start to take Huawei equipment out of their networks and stop purchasing new Huawei equipment according to those restrictions. So Ofcom's role there is actually quite limited. We collect some information to kind of monitor how that process is going, but no more than that. It's really between government and the operators. So if you know, those who are affected by that will already have had directions from government on it. So I'll say no more about that. The rest of the framework, which is the bit that we concern ourselves with, is kind of actively monitoring and understanding the security measures that the operators are putting in place. And then ultimately we have kind of enforcement powers there. So if we don't like what somebody's doing, we don't think they're following the rules, then we can ultimately we can fine them. But that's kind of not where we start from. It's more of a backstop position. Really, our role here is monitoring what the public operators are doing, and that they're complying with the new obligations. Next slide, please. So there's three parts, and I'll talk about each of them briefly. It's somewhat more complicated than a lot of the regulation and legislation that applies in having these sort of three legs. We've got the primary legislation, the Act itself, which has now moved over into the Communications Act, which essentially covers most of Ofcom's work in relation to telecoms companies. And that sets the sort of high-level duties on providers. And I've got a slide just to touch on what they are in a moment. Sitting below that is secondary legislation, or the regulations document. This has a lot more detail. There's somewhere around 60 individual regulations in here that are particular outcomes or things that operators need to achieve. But again, this is still legally binding. You know, this is the law. You must do this if you're a relevant public provider. And then finally, on the right, the document that I'll mainly be focusing on today is the guidance, or code of practice as it's called. Now, this isn't binding, this is advice, this is guidance, but it is statutory, so it does have a particular role. We, as the regulator, have to take it into account when we're deciding if an operator has or hasn't done what they need to do to comply with their legal obligations in the left-hand two documents. And it provides a lot of very granular detail on sort of general advice on how to secure your network, and then some specific technical controls that you should implement in order to ensure that you're complying with your obligations. So I'll touch on each of those in turn now and focus, as I say, mainly on the guidance. So next slide, please. So just before I get to that, there's a number of parties involved here. So as I've said, we have this role in monitoring and enforcing compliance with the duties. Government under the auspices now of DCIT, although previously it was the department, DCMS, Department of Culture, Media and Sport, who create the legislation and publish this guidance, and they have kind of an ongoing ability to publish updated guidance from time to time when they think the world has moved on sufficiently, or there's other things that they want to say. So DCIT's role at the moment is somewhat in the background. NCSC, the National Cybersecurity Centre, for those who aren't aware, they're the sort of cross-government department with responsibility to be the technical authority for cybersecurity in the UK. So they produced the technical guidance, which ultimately ends up in the code, and we work very closely with them on the regime to help inform us on the kind of technical aspects and so on. Next slide, please. So moving on now to the Act itself, and at a high level, this essentially places an obligation on the public providers to identify the risks of a security compromise, reduce those risks, and prepare for what might happen if they do, so recovery, minimising the harm, and so on and so forth. There's also an obligation on them to report significant security compromises to Ofcom. And security compromises is defined quite broadly. It can be things that you might think of as a cybersecurity incident, or anything, in fact, that affects the availability or the confidentiality or integrity of the network. So things such as floods and power outages and equipment failures and things are potentially all reportable to us, depending upon the impact that they have. Next slide, please. So as I say, sitting below that then is the regulations, which goes into more detail, essentially breaks that whole problem of running a network apart into various components. So and puts particular requirements on people to, for example, keep their software patched and up to date, undertake regular testing, make sure that the people that they have in place have sufficient competency and the proper governance processes and so on around it. So again, these, whilst there's a lot more of them, they're still fairly high level. They don't really tell you how to do this, just what you need to achieve. And that's really where the code comes in. Next slide, please. So this is the document I'll be focusing on for the rest of the presentation. It's reasonably easy to find, and I would definitely recommend, if you're interested in this area, that you go and find it. If you just Google communications security code, it usually comes up pretty quickly. But if you have any trouble, then do let us know and we can point you in the right direction. Next slide, please. So what's in the code? So it's kind of in two parts. The first is a more narrative section that explains some of the key concepts to think about in deploying networks in relation to security, and then goes through each of the key areas that are important. Now, for those who are familiar with security, a lot of these concepts will be familiar from other frameworks like the NIST framework, some of the ISO standards and so on. There's only so many ways to do security. Where this document, I think, is particularly valuable is it comes from the perspective of NCSC, who've got a wealth of experience, world leading, on understanding the real world attacks and threats that large-scale telecoms networks are actually under day to day. They have a lot of information there about what's actually happening, and they've thought very hard about the measures that a provider of those networks can take to best protect themselves against the sorts of things that they're really going to be facing in real life. So as well as the more kind of foundational things here, much of which, as I say, will be familiar to anybody who's thought much about security of networks, there's much more detailed advice that's specific to the telecoms context that can be extremely helpful. So the first section of the document goes through all of these kind of concepts. Again, quite a lot of overlap here with the regulations, unsurprisingly, because this document is intended to guide the operators who have to comply with the regulations on how to do that. Next slide, please. And then the second part of the document, which kind of summarized here, is then a set of more detailed technical measures that providers should take. And if the sort of general idea is that if they took all of these measures, they're very likely to be compliant with the majority or all of their legal obligations. And they're divided up in these kind of ways. To talk about the columns on the right, the tiering and the timescales there. So this regime applies to all providers of public networks and services, regardless of their size, apart from the very smallest micro entities. But it kind of acknowledges that the context for a large £1 billion annual revenue telco and national telco of the likes of the MNOs and so on, the context for them is going to be very different to a much smaller entity. So divides the market into kind of three tiers. There's this £1 billion plus tier. Tier 2 is for companies with turnover between 50 million and £1 billion a year, and then smaller companies are in tier 3. And the code is particularly focused as being applicable for those tier 1 and tier 2 companies. However, it makes the point that the security measures in there are absolutely something that are useful to tier 3s as well, and indeed, I would say to deployers of private networks also. So whilst the legal obligations are in force now, they've been in place for about a year, the code again acknowledges that making some of these, putting in place some of these security measures is going to take operators time. And this can largely be because of their kind of legacy. A lot of operators have got networks which have been in place for many, many years and just weren't designed with some of these security issues in mind, and therefore implementing the protections, the controls can be very difficult. It can require replacement in some cases, and that's all going to take time, of course. So the measures are kind of ordered, those that seem either kind of easiest or at least most urgent, things that operators really can and should be doing soon, and things that the framework acknowledges is going to take a few more years of development before we have all that stuff fully realized. Next slide, please. So I've got a couple of slides just to pick out some examples, and then one final one to wrap up. So in terms of the types of things that are in there, and this speaks again to this idea that this is primarily concerned with how you deploy your network, not the kind of underlying technical controls built into the 5G standard, for example. Privileged access workstations feature quite heavily as a theme within the code, and this is the idea that if you, for example, have an administrator or a manager who's working on your network, and they're using the same computer that they use to browse the web and do their email, etc., you have to assume, from a security point of view, that a sufficiently motivated bad actor will ultimately be able to infiltrate that laptop via the internet, and you can assume that they're there and they're kind of persistent on that laptop. If you then allow that same device to connect to the management interfaces on your network is effectively owned by the bad actor at that point. So this privileged access workstation is a mechanism to try and kind of avoid that, essentially, and that can be for your own employees and engineers, but also for third parties who run or administer the network on your behalf. So there's quite a lot in the code about that. Virtualization is another area, and it was kind of touched on earlier, that particularly in 5G private network context, it may be that the entire network is running on a public or private cloud in a fully virtualized fashion. So it's not built using sort of old-fashioned dedicated boxes. And that running of your network, essentially the core functions of your network on a shared computing platform, whether it's under your control or somebody else's control, brings a whole range of new security risks. And so the code has quite a lot to say about how you can best manage some of those sorts of risks. Next slide, please. And then the final slide on the kind of content is the security of the supply chain. I think this is a topic that comes up increasingly now, the realization and understanding that you really need to understand the whole supply chain for a network if the resulting final network is to be secure. So that's both about ensuring that the people that you buy things from directly operate in a secure fashion, but also that the people that they use in their supply chain do likewise. So building on a document which NCSC had published on its website for a while, actually, the vendor security assessment, that gives a lot of quite detailed guidance on the types of things that you should be seeking when you're entering into contract with suppliers to ensure that their hardware and software development processes are secure, for example, that they have proper lifecycle management, that they're going to update and patch things, they're going to withdraw things in an orderly fashion. A lot of things that you would hope are common practice amongst vendors, and for some vendors they are, but there's plenty of stuff in there that's less common. So there's a lot of really good stuff in there. And so, yeah, another kind of useful area in the code, I think, to bear in mind. Next slide, please. So this is my final slide. So I guess my sort of recommendation is for anybody who's interested in understanding more about security, please do go and find the communications code of practice and have a look at it. There's a lot, as I say, of useful things in there which I think are absolutely applicable in any kind of network deployment context, be that public or private. The other thing that we've found through our experience is that testing is incredibly valuable. In particular, we've got a testing scheme which we set up jointly with DCMS at the time, the government department, and NCSC. It's a kind of voluntary scheme where we invite large telecoms operators to get involved in what we call kind of red team type testing. So this is different from commonly used vulnerability scanning and so on. Here you actually hire a team of tame bad guys to go and try and break into your network. And this is performed on live networks without the knowledge of the security teams, the defenders. So it is as close a simulation to a real attacker trying to attack your network as possible. And for every single one of these tests that we've done, everybody has learned an enormous amount about the ways in which their network may still be vulnerable, even though they've put in place lots of protections. So we can't really underestimate how useful and valuable this type of testing is, but it is not a cheap undertaking, it has to be said. So that's it from me. Thank you very much. And I will hand back to Roberto.
Thank you very much for that, Ben. I think it marries quite well with the idea of, 5G being a secure, private 5G being a secure network. And particularly if you're providing those mission critical services in a factory or wherever as an SME, then, if you can take the experience from what's happening in the real world and people trying to access networks, that can be very valuable. And I guess bad actors can do it just as kind of ransom, really. I use Garmin. Apparently that went down a couple of times for that was the rumor reported anyway. So with that, could I ask the other panelists to turn their cameras on and we can do a quick Q&A? And obviously, thank you very much for your presentations. They were all very good, and I think they give a good overview for an SME that's interested in this area. What are the sort of things that private 5G can be good for? What's happening in the market, particularly from Andrew, the sorts of products and services available. Then, okay, if you decided that you wanted to use a network, how would you go about it? How would you approach Ofcom? Jack's slides particularly useful for doing that. And then Ben's slides are very useful for, okay, if I've got a mission critical service, if I want to take advantage of the inherent extra security in private 5G, how can I do that? And perhaps referring to the code of practice gives you a good overview of what's happening in the real world in terms of attacks and hacks. So we did have some questions for this webinar. So the first question was, can the panelists see 5G replacing hardwired Ethernet networks within offices? Andrew, did you want to perhaps go on that one first?
My recommendation is always, if you can hardwire, it's always more reliable. A wireless system is always subject to potential for interference and also eavesdropping, because it is a wireless system. So, there are a lot of people who just use Wi-Fi and that in an office anyway. I'm currently on a Wi-Fi connection, so I think it's horses for courses.
Okay, so definitely kind of 5G is an add-on rather than a replacement.
Yeah.
Ben, Jack, do you want to say anything on that? You don't have to. Okay. So how do you determine the areas where 5G signal is available and areas where it is not? I guess that's very important for an SME that wants to set up a private 5G network, how much they can rely on the public network and how much they really need to have something bespoke built for their facility. I don't know, Jack, whether you want to say a few words on that?
Yeah, so in terms of the public 5G footprint, there's information available from the mobile operators on their websites, and there's information available on the Ofcom website as well. So you can enter your postcode on the Ofcom mobile coverage checker, we can find on the website, or just Google Ofcom mobile coverage checker, and it will provide you with information for good coverage generally, and also the option to select for 5G coverage. And then we provide a view based on our assessment of the information that the operators provide to us as to whether that coverage prediction is with high confidence or very high confidence, which takes you sort of towards 90% plus chance that the coverage is there and would be reliable. So that hopefully provides a good insight into where 5G is available on the public network. what I would say is, you might in the future also be interested as to whether that 5G that's available on the public network supports 5G standalone, so 5G that operates independent of the 4G network, and that's something that we'll be looking to provide more information on in the coming months. It's also worth saying that the information that Ofcom provides is currently for outdoor 5G coverage, and that is something that we'll also be looking to provide more information on in the coming months. But certainly in terms of that 3.8 to 4.2, in terms of the 3 gigahertz 5G spectrum, it is more challenging to get those higher frequency signals indoors at a good quality, and that's something that we're looking to provide an updated view on, but it's worth keeping in mind. Now, that's all in terms of what's available on the public network. I think important point to stress is that what's available on the public network need not necessarily be a limitation on what can be delivered on the private network. So you don't necessarily have to have that public network coverage to provide the private network coverage, as long as there's appropriate sort of backhaul solutions in place. And to understand what's available or what's possible on the private network side, as I say, Ofcom needs to undertake these sort of case-by-case local coordination checks to ensure that sharing is possible. But you could take a look at the information in the Spectrum portal that I pointed to give a sense of how much activity there is in a local area, and therefore whether Spectrum is likely to be available. So that's not quite the same thing as coverage, but it's a relevant consideration as well.
Yep, thank you very much for that, Jack. Anybody else want to comment on that? Okay, so the next one is how easily can SMEs access spectrum for private networks? Is an easier process needed? And I guess I'd ask you to comment on that one first, Jack.
Yep. So hopefully I've given a broad overview in my presentation of the access process. The process that we've got in place, we've set up in a way that we've tried to make it as simple and user-friendly as possible. And the types of information that we need are relatively high level and should be fairly straightforward. Now, one of the things that we certainly have heard from stakeholders is that if possible, they would welcome a faster process and turnaround time to undertake that check of whether the spectrum is available and then for the license to be issued. And that's something that we're aware of, and I've mentioned the fact that we're looking at the moment at ways we could update the processes that we have. We have a plan to bring some more automation into our licensing processes in the coming years, and that will start with moving some of these shared access application processes online next year. So hopefully that will be another step that helps to simplify things further for interested parties.
Okay, thank you. I mean, one of the things that I've heard is that people are interested, as Andrew was saying, if you use private 5G, you can have fewer nodes or base stations covering an area. But I guess that depends on the powers you're allowed. And I think you mentioned there are some restrictions between urban and rural areas. So I mean, do you see this kind of current power level as being okay, or is there going to be a discussion on how you can get higher powers? And I don't know whether Andrew has a view on the sort of powers that he would like to see on private 5G. Andrew smiling, maybe you want to say something, Andrew.
So I mentioned that we've got a consultation forthcoming, and I would say there's not too much more I can say on that before consultation. I think what I would say is, of course, we recognise that from a user perspective, access to higher powers comes with a number of benefits for the individual user, but this is shared spectrum, and what we would really like to enable and support is sharing from lots of users in nearby locations, and therefore you have this balancing act between the power and preferences of an individual user and potential impacts on other users. So hopefully the framework that we've got is already, we've seen a lot of take up and it's supporting a lot of things to be done, but we're always looking and thinking at that balancing act.
Okay. Thank you very much for that. So another question I had was, how easy or complex will it be supporting and fixing private 5G networks compared to maybe Wi-Fi and other networks? I don't know whether, Andrew, you have a comment on this?
I would say at the moment it is more complicated than a 5G, than a Wi-Fi network, given that you can pretty much just roll into your local high street or order a Wi-Fi access point on Amazon and just plug it in and go. So I think it is more complicated at the moment. It does require a bit more thought about the radio planning, but the tools that are beginning to be developed and coming on market make it much easier. So I think it's a bit like the same story as the cost of deploying private 5G, that this difficulty will decrease over time as people become more used to using the network and understanding the tools. So I think it's something where you probably need somebody who's got a bit of experience, who's in that area at the moment, but as the market grows and it's becomes more common, then that barrier will fade away.
Okay. And the final question I have is, obviously the attractiveness of this for SMEs depends on the costs, and the costs will be driven by economies of scale and how the markets are moving and how Europe is moving. And so how do we see the market progressing? And when I looked at Jack's slides, I think he had a few hundred networks in the kind of 3.8 or 364.2 band, which is where you'd see private 5G. How do people see this market progressing in the next 2 or 3 years, which might be the time horizon an SME would be interested in?
As I said, the government has been putting a lot of support into the development of O-RAN, which has brought in a lot of new equipment supplies in the market. So you're no longer bound to go and buy radio equipment from Nokia or Ericsson, and that has significantly reduced the cost of entry into the market. And there's a lot been, I mean, in the last couple of years, there's been a lot of innovation, and the cost of this equipment has fallen dramatically even in the last 2 years. So I think the radio core, the core network, the 5G core, that is just a software product, and again, as more of it becomes rolled out, the cost of that will go down. There's always the option to purchase these things online and try it and see how you go. So you had some pricing from Amazon. Organisations like Athernet have just been purchased by Hewlett Packard, and they offer an online service. So you can buy these services by the month and just try it and see whether it fits your use case.
Okay, thank you. Jack, Ben, do you want to add anything? Any bottlenecks or things that you think will be made easier in the next 18 months, 2 years?
I mean, certainly from the stakeholder engagement that we have, there are a lot of active players in this space, and most of them are telling us that they expect to continue to see sort of significant opportunities and uptake. I think you alluded to earlier in the discussion, Roberto, some of the conversations that's going on across Europe, where we've seen some regulators already adopting similar approaches to the approach that we've set out in the UK, and discussions going on around potential harmonisation for shared access, which, as you say, could help drive economies of scale. And perhaps the other point I would note is over the last year or so, 3GPP, who got a name check earlier in the discussion, have also brought forward what's called a reduced capability or RedCap standard for 5G that supports sort of the core components that you would expect for 5G industrial applications, but in a slightly streamlined way. And there's potential for that again to contribute to lower price points moving forward that might make more attractive for users.
Thank you, Jack.
And I'll just say, on the security is often not a very welcome participant in a conversation like this, because it only tends to put costs up, unfortunately. But again, if your use case is to better be able to conduct your critical comms, then it's probably not optional. A bit like Jack mentioned there, this kind of model, the code has been widely shared internationally, and we're finding now that there are a few countries within Europe and beyond who are interested or already are adopting very similar looking frameworks. One of the things that we are starting to see happen is that particularly the larger vendors at the moment, but we expect it to flow down to some of the newer kind of open RAN vendors and people that Andrew was talking about, are starting to kind of adopt some of the principles in the code as their sort of standard practice, publish statements on their websites, for example, with a bit more transparency and disclosure about how they do their software development, for example, which is often in telco space something that we haven't really seen. It's been a bit of a closed, sort of security by obscurity approach in telecoms often, as opposed to internet, for example, which is much more open by sort of default. So we're starting to see that flow through, and as it does so, it should mean that some of these security features sort of come as standard rather than being things that people are going to have to, work very hard to negotiate into their contracts and so on.
Okay, well, thank you very much. Are there any further comments people want to share before I go into kind of rounding up as best I can? Okay, so I think we've learned that there are a lot of opportunities for private 5G for SMEs. There are lots of things that private 5G can offer, the massive IoT, the mission critical services, and the different options people have to connect. And that security is an important issue, as Ben has pointed out, especially if you're providing mission critical services, which is one of the key advantages perhaps for private 5G in an industrial production setting. So that's very important. Jack's highlighted that Ofcom is making the spectrum available in an easy manner and consulting with stakeholders to make it available as easy as possible, and that there are steps within Europe to harmonise on frequency bands. And although that's can appear slightly esoteric, it's obviously a big issue in driving down costs, and it's the sort of thing that made 2G much cheaper than before when harmonisation happened. So that's a big benefit. We've also heard from Andrew that there are a number of ways to provide these services, and that they can be used in a number of areas which are very important, and that harmonization and costs are coming down, which could make this a very attractive technology, not one that will replace your existing technologies, but one that sits above maybe Wi-Fi and actually cabling up devices, but offers you more flexibility in industrial processes. And as the price comes down with harmonization and economies of scale, this can be used more and more widely. And you have different options, as I mentioned in my slides. You can either go to the MNO and ask them to build you a dedicated network. You can go to a hybrid provider, perhaps such as Andrew's EMS, who will build a network for you, or you can build it yourself. Each of those options has its own pros and cons, and it will depend on what situation you find yourself in, and perhaps the quality of network you need versus the quality of network that the existing networks can offer you, such as public 5G and Wi-Fi. So it's an interesting time. Things are evolving, and I think this is an attractive technology, and it has a lot of interest around the world. So with that, I'd like to thank our three speakers, Andrew Lambert, CEO of EMS, Jack Henley, Policy Principal at Ofcom, Ben Willis, Principal Technology Advisor at Ofcom also, and I'm sure they'd be happy to take questions if you want to send them in via BSI. So thank you very much, everyone. Thank you. Goodbye.